Hello again. We're going to talk tonight about a upper stage or a second stage booster rocket from SpaceX that is going to hit the moon this coming Wednesday in the wee hours of the morning Eastern time. So here's the full synopsis. What's going to hit when and where? So I had to quickly put this together because this is going to happen on Wednesday. So I've got to get this out quickly. It's a SpaceX Falcon 9 rocket upper stage or second stage. They did the trajectory calculations, and it turns out it's going to land in the vicinity of a crater called Einstein, which is on the western edge of the moon. If you're looking at the moon, we're looking at the near side. It'll be on the left, right at the edge. It's within known as the western limb or the libration zone. The moon kind of wiggles back and forth. Sometimes a bit of the Einstein crater is not visible. So this will be like more than 2/3 of it will be visible. And so you should be able to see this area of the moon. It's not expected to have an explosion. The rocket tanks have been emptied long ago. Kerosene and liquid oxygen have been invented. So it's just a big empty double tank with a rocket engine on the back. It's not expected to make a huge crater, although it's megaton class. As far as the impact force goes, it's traveling slow compared to an asteroid or a meteor impact. And the angle is going to be about 30 degrees. So it's not a face-on full impact. It's probably not because there's no explosion, and we're facing the facing side of the moon, and the moon is going to be sunlit in that portion. It's like a first quarter or something moon, and so there'll be a lot of light on that part of the moon. So you probably won't see the impact itself, and it's going to be hard to see even if you have a major telescope because the contrast is going to be so low. But since it's close to the edge of the moon, if it hits it from, let's say, the east side going to the west, that will kick up a plume headed towards the limb or the horizon of the moon. And you might see that for about 30 minutes. That's called the ejecta or the dust plume. And you might see that for about 30 minutes. If you're looking at the right time in the right place, skies are clear and the moon's up high enough, so it's not within the horizon distortion field wherever you're at, then you might see something. But if you want to know the details, down in the lower right is the big picture of the side of the moon facing us. And you can see Mare Imbrium, the big sort of thing with the like mouse ears on top of it. If you start there and then you track west, you'll see a bright crater that's called Aristarchus. And then you keep tracking west towards the edge. You'll go past Eddington, Balboa, Dalton, and right at the edge, you'll see Einstein. And it's about 15 degrees above the equator of the moon. Well, not really the equator, but from our perspective, if you cut the moon horizontally along the middle, it's about 15 degrees up. So that's where it's expected to hit. I don't have exact coordinates because they're still finalizing it. The time will be plus or minus a few minutes because remember, this thing is not on a rocket propulsion trajectory. It already finished that. And now it's on whatever the sun delivers in, radiation, reflection, pressure against the outside of the spacecraft, pushing it to change its orbit. So they're calculating the orbit every time more sun hits this thing. So effects. Will the moon continue to exist after the impact? Yes, this is minuscule compared to the moon. Will the moon be damaged? Yeah, there'll be a crater about 40 meters across, maybe a little less. So not significantly. Yes, there will be a short-lived ejected dust plume and a small shallow crater. The crater will be 40 meters, 130 feet. The lunar reconnaissance orbiter, which is in orbit about the moon, will be able to go in and take pictures of it after the fact to see exactly where it impacted. Because it's got before pictures already took. So once it impacts, it can do a comparison and go, oh, there's a new crater. After. Is the impact going to affect life on the Earth? No, except in social media and conspiracies. Was there an international law that could have prevented this? No. Has it ever happened before? Yes, as a matter of fact, deliberately, they took the third stage of the Apollo launch vehicles, and they deliberately directed them to impact the moon after Apollo 11 because they had these seismometers that Apollo 11 dropped off on the moon to study moonquake. So by having a big, heavy third stage whack into the moon, they could study these seismic effects, and that's where they got the phrase, the moon rang like a bell. What that means is the moon is rock, not a lot of like magma inside of it, And so it kind of rings like a rock being struck by a hammer. Is this impact deliberate? No, actually, there's no way to control it at this point. The booster delivered its payloads for lunar landing. It was in a long elliptical orbit because that way it could get to the moon, and then it was going to come back. And if it ever decayed its orbit around the Earth, then it would burn up in the Earth's atmosphere. That didn't happen because the radiation reflection pressure from the sun actually pushed it into a different orbit, and therefore it coincided with the orbit of the moon around the Earth, and now you have an impact. Why doesn't this happen all the time? We're launching stuff all the time. There is this area of little concern called cislunar, CIS lunar. That's where you've launched something that's left the Earth, and it's left the Earth with enough force that it might go out to the moon and back around. It might go in orbit around the moon. It might go well beyond the moon, out to like L2, and then want to come back. The ones that go out to L2 and then want to come back, they actually have enough leftover fuel to take the upper stage and kick it into a sun orbit. So eventually they'll burn up in a solar orbit in the sun. There's lots of junk out there that goes into cislunar that winds up like this. Where's it going to land? Well, if it comes back to the Earth, it's going fast enough, it'll probably burn up. Where? We don't know, but it's going fast enough, it'll burn up in the upper atmosphere. If it's planned to be cislunar, but it winds up heading out towards the sun, that's fine. The sun is big, has large gravity, and will pull it in. But it could hit the moon. There's no other impacts that we know of planned at this time, but you never know. I saw it as, hey, this is an observing opportunity. Ring the gong and let everybody know there's something you can look at. We know where about it's going to hit. We know when. It's going to be difficult to image it with a camera because the moon is brightly lit. If the moon was in a new moon state, maybe we could see the impact better. But since it's not going to explode, you need some sunlight on it. Otherwise, it's just going to be in darkness. It's small enough, you're probably not going to see it with the small telescope. But larger telescopes on the ground that have higher contrast might be able to see it. Maybe, who knows? Space telescopes. Remember, there are space telescopes out at L2 that stay out there, and they can never look back at the moon or the Earth or the sun because it would blind them. However, this impact is on the near side, the Earth-facing side of the moon. So even if they could turn around at L2 and face the moon, they would be facing the far side of the moon and not be able to see it. There is an Earth-orbiting space telescope that might be able to see it if it's not going to be blinded by the moon, and that would be the Hubble Space Telescope. The plume might be visible over the edge of the lunar horizon for about 30 minutes. I teed up my radio astronomy community friends at Sarah, and I got kind of a 50-50 of, no, you're not going to get any radio signals back from that. That's not possible. But they won't spend the 10 minutes of radio observing time that, this thing is made out of an aluminum lithium alloy, and it's going to be striking silicon. And you could get a stray radio signal from the impact that would be sizable based upon the speed of the impact. But the senior folks at Sarah are like, nope, not going to happen, not going to happen. But they won't spend the 10 minutes to observe, I guess because it's 2:34 in the morning. But also made me think that the gravity wave observatories that we have, the LIGO, the Virgo, the Kagra, those kind of places, maybe given how much tonnage is going to hit the moon and it'll cause the moon to ring like a bell, as the saying goes, maybe it'll create a gravity wave distortion that they can pick up. But they're always listening. So if it happens, they'll go, what was that? And then they'll realize, oh, that was that thing hitting the moon. But we'll see. So on Wednesday, August 5th at 2:34 a.m. Eastern Time, there'll be the upper stage of a Falcon 9 hitting the moon in the vicinity of crater Einstein near the western limb on the Earth-facing side of the moon. Probably not going to be able to see it. There's no explosion. The plume might be visible. The Lunar Reconnaissance Orbital will definitely follow up and let you know where it hit. This happens from time to time, sometimes deliberate, like during the Apollo program, but not this time. This one was solar radiation pressure. These things happen. The moon gets impacted lots of times, and LRO has taken pictures before and after and went, oh, look, something hit the moon, and we didn't even see it. There's a new crater. Given how much detail we already know about this thing and the number of people that are aware of it, maybe we'll get some new science out of it. And then if you want to know about a Falcon 9, the news about the impact, how it was actually trajectory tracked and the planning for where it would impact. There's actually a science research paper on that. And then if you want to know more details about Einstein crater on the moon. Comments, questions? Anybody staying up at 2:34 on Wednesday morning?
I will set my alarm. I may take my telescope out just to see what happens.
I'll probably be awake at that time. We'll probably go outside and take a look. But I did the calculations and the angle, the azimuth. In other words, from my house, if I wanted to look at the moon at that time of day, it's going to be about 89 degrees. So that's just north of east. So it'll be in a good direction to look. Sort of out. If you were on the ocean, it'd be great because you could look up above the sea and see it. The elevation is about 35 degrees. And for me, from my front yard, that's not possible because I've got a lot of trees in the backyard that go up to about 40 degrees. So I won't be able to see it from there. If you plan on observing it from Fort Lauderdale Beach, know that they have parking restrictions from 2 a.m. to 5 a.m. Bummer. But you might be able to, let them know, hey, I'm here with a telescope. There's going to be an impact on the moon, and there's the moon, and I can see it here above the ocean. That's great. You have to explain that to the officer when he attempts to give you a ticket for parking during the no parking time zone.
Well, if it's low on the horizon, I won't see it from my house then, for the same reason you won't. I got houses and trees.
Yeah. Like I said, it's around 35 degrees above the horizon. So if at 2:34 in the morning, you can look due east, but you can't look lower than about 40 degrees, you won't see it.
What is the weather supposed to be like?
Southeast Florida in the summertime. It's overnight weather. If you've ever noticed it, the rain, showers, and thunderstorms occur in the late afternoon and before the evening. So hopefully it will have gotten all of that out of its system by 2:30 in the morning.
Excellent.
Remember, you can't see it naked eye.
Oh, okay.
So I would say if you're other than an avid observer, watch the video like the day after. I'm sure there's going to be lots of video of it from actual observatories showing it doing its thing. But yeah, but you never know what you're going to see until you see it. Will I set up a radio telescope and take it out to Fort Lauderdale Beach? If you really want to be arrested, it's spooky enough for you to be watching the moon with a telescope. You bring out a parabolic dish antenna pointed at the moon and a laptop computer with electronics, and yeah, you're just asking for lots of questions. But my Sarah radio astronomy friends were saying if the aluminum lithium material, when it did impact, produce a radio noise spike, it would be at the 3 gigahertz level, which is well above my software-defined radio receiver. It's deep into the infrared, which means you wouldn't be able to see it below the Earth's atmosphere as far as a radio signal. Maybe Hubble will be pointed at it. Who knows? Okay, any other comments or questions before I stop recording? Hearing nothing.